If you were standing in the parking lot of the Denny's in Palmdale, California 3 days ago, you didn't hear a jet engine. You heard the sky tearing in half. It wasn't the sharp crack whip of an F-16 breaking the sound barrier. It was a double thump, a deep, resonant geological event that rattled windows all the way to Bakersfield. For 40 years, that specific acoustic signature belonged to only one ghost, the SR-71 Blackbird. But the Blackbird is in a museum, and what flew over the Mojave on Tuesday wasn't a surveillance sled built with 1960s slide rules. It was the United States Air Force officially taking the gloves off. Welcome to the reveal of the Boeing F-47 Pegasus. For the last 18 months, the defense community has been fighting a civil war over this airplane. We heard it was canceled. We heard it was paused. We heard it was too expensive, that it was a dinosaur in the age of drones, that the program had collapsed under the weight of its own budget. We were wrong. While we were arguing about drone swarms and budget caps, Boeing and the Air Force Rapid Capabilities Office were finishing the most terrified engineering sprint in history. They didn't just build a replacement for the F-22 Raptor, they built a time machine. The leaked telemetry from this week's test confirms a sustained cruise velocity in excess of Mach 3.4. That is not a sprint, that is a cruise. That means this aircraft can leave a missile battery in Shanghai, fly to the edge of space, and be parking in Guam before the enemy radar operator even realizes he missed. This is the most expensive fighter jet ever built. It is a $350 million spear thrown right at the heart of the Pacific. And today, we are going to tear it apart, bolt by bolt, dollar by dollar, to see if it's a strategic masterpiece or the most dangerous financial mistake the Pentagon has ever made. I'm the lead analyst for the Hidden Muster. Let's break it down. To understand why this machine exists, you have to go back to the panic of 2023. In the early 2020s, the United States Air Force ran a series of classified war game simulations, a conflict over Taiwan in the year 2027. The results were catastrophic. The F-22 Raptor, the undisputed king of the sky for 2 decades, was losing. It wasn't losing because it wasn't stealthy, it was losing because it had short legs. The F-22 has a combat radius of about 450 nautical miles. In the Pacific, 450 miles is nothing. It's a rounding error. To fight over Taiwan, F-22s had to rely on aerial refueling tankers, and the Chinese knew that. In every simulation, the enemy didn't bother fighting the fighters. They just shot down the slow, fat KC-46 tankers. The F-22s ran out of fuel and fell into the ocean. The Air Force realized they needed a plane that didn't just hide from radar, but one that could fight from bases so far away, Hawaii, Australia, Wake Island, that Chinese missiles couldn't touch them. They needed range, and they needed speed to close that distance fast. This birthed the NGAD program, Next Generation Air Dominance. But then, in 2024, the program hit a wall. Secretary of the Air Force Frank Kendall famously paused the competition. Why? Because the price tag was coming in at $300 million per jet. For the price of one NGAD, you could buy 3 F-35s. For the price of one NGAD, you could buy 50 high-end autonomous drones. The debate in the Pentagon was vicious. One side argued, the era of the manned fighter is over. Build robots. The other side argued, robots can be jammed. We need a human brain in the fight to make the kill decisions. The human-in-the-loop faction won, but they had to make a compromise. The F-47 would not be a lone wolf dogfighter like the F-22. It would be a quarterback. It would fly fast, stay high, and command a swarm of cheap, expendable drones that would do the dying for it. When Boeing won the contract in March 2025, beating out the heavy favorite, Lockheed, it shocked the industry. Lockheed is stealth. They built the F-117, the F-22, the F-35, but Boeing offered something Lockheed didn't, a radical manufacturing approach borrowed from their commercial airliner division, promising to print these jets faster than anyone thought possible. That promise is now flying over California. Before we look under the hood, we have to look at what this thing is hunting. For the last decade, the benchmark has been the Chengdu J-20 Mighty Dragon. It's a good jet, it's fast, it's stealthy, and China has built over 300 of them. But the J-20 is a 5th-generation fighter. It's an F-22 peer. The real threat, the one that keeps Pacific Command admirals awake at night, is the Shenyang J-50, sometimes referred to in intelligence circles as the JXX. We have seen satellite imagery of the J-50 taxiing at remote test bases in the Gobi Desert. It is a flying wing, no tail, no vertical stabilizers. It looks like a B-2 bomber flattened into a fighter. This design is optimized for broadband stealth. Here's the physics lesson. Traditional stealth fighters like the F-22 and F-35 are invisible to high-frequency fire control radars, the X-band radars that guide missiles. But they are actually quite visible to low-frequency search radars, L-band and VHF. The J-50's flying wing shape makes it invisible to everything. Low frequency, high frequency, it doesn't matter. It is a ghost. If you can't see the enemy, you can't shoot them. So how do you beat a ghost? You outrun it. The J-50 is subsonic or low supersonic. It trades speed for stealth. The American doctrine with the F-47 is to flip the board. The F-47 uses speed as a weapon. By cruising at Mach 3, the F-47 imparts massive kinetic energy to its missiles. Think of it like throwing a baseball. If you are standing still and throw a ball, it goes 90 miles per hour. If you are driving a dragster at 200 miles per hour and throw the ball, that ball starts with a 200 mile per hour head start. An AIM-260 missile launched from an F-47 at Mach 3.4 has nearly double the effective range of the same missile launched from an F-22 at Mach 1.5. This allows the F-47 to shoot at the J-50 before the J-50 can even get into range. It's not a dogfight, it's a drive-by shooting at 3 times the speed of sound.
Now let's get technical. How did Boeing actually build a Mach 3 stealth fighter? The engineering challenges here are contradictory. The thermal wall. When you fly at Mach 3, friction with the air heats the skin of the aircraft to over 800 degrees Fahrenheit. At those temperatures, aluminum softens like butter. Titanium holds up, but it's heavy. Worse, the radar-absorbent material, RAM, the special paint that makes the jet stealthy, usually melts or peels off above Mach 2. This is why the SR-71 leaked fuel on the runway. It had to be built with gaps to expand when it got hot. You can't have gaps in a stealth fighter. Gaps reflect radar. The F-47 solves this with a material breakthrough, ceramic Matrix Composites. Boeing and GE have spent billions developing these materials. They are woven ceramic fibers embedded in a ceramic matrix. They are as strong as metal, but they weigh 1/3 as much, and they can handle temperatures of 2,400 degrees Fahrenheit. The leading edges of the F-47, the nose, the wing roots, are likely not metal at all. They are unified ceramic structures. The cranked kite planform.
The shape of the jet is what we call a cranked kite or a modified delta. If you look at the leaked silhouettes, you'll notice something missing: the tail. Vertical tails are the enemy of stealth. They act like mirrors for radar, but they are necessary for stability. If you remove the tail, the plane wants to flip over. The B-2 bomber solves this with drag rudders, but those kill your speed. The F-47 uses active flow control, AFC. Instead of moving a physical rudder, the wing surfaces have thousands of tiny holes that eject compressed air. These blasts of air change the pressure over the wing, steering the jet without any moving parts. It's fluidic flight control. It reduces drag, reduces weight, and eliminates the radar reflection of a tail. The skin that breathes. There are rumors, unconfirmed but persistent, that the F-47 utilizes transpiration cooling. This means the fuel on board isn't just for burning, it's for cooling. The fuel is circulated under the skin to absorb heat, and in critical hotspots, microscopic amounts of cool air are bled through the porous ceramic skin, creating a boundary layer of cold air that protects the jet from the Mach 3 friction. The aircraft literally sweats to keep from melting. The record-breaking speed comes from the engines, and this is where General Electric has changed the game. The F-47 is powered by two XA-102 adaptive cycle engines. To understand why this matters, you need to understand the bypass dilemma. Turbojets, like on the old F-4 Phantom or SR-71, are great for speed. All the air goes through the core. They are loud, powerful, and thirsty. Turbofans, like on an airliner or the F-35, are great for efficiency. Most of the air goes around the core, bypass. They save gas, but they hit a drag wall at high speeds. For 50 years, engineers have had to choose. Do you want to go fast, turbojet, or go far, turbofan? The F-47 needed to do both. It needs to cruise efficiently for 2,000 miles to get to the fight, and then sprint at Mach 3 to survive the fight. The XA-102 is a 3-stream engine. It can change its geometry in mid-air. Cruise mode, it opens a third bypass stream. It acts like a fuel-sipping high-bypass engine. Combat mode, it shuts the bypass. It forces all the air through the core, turning it into a screaming turbojet. But Mach 3.4? That requires something extra. Analysts believe the XA-102 features a ramjet injector stage. At speeds above Mach 2.5, the turbine blades in a normal engine become a liability. They can't spin fast enough to compress the air because the air is already moving so fast. In the F-47, it is highly likely that bypass air is routed around the turbine and ignited directly in the afterburner section, essentially turning the engine into a ramjet. The faster it goes, the more efficient it becomes. This is how they broke the Blackbird's record. The F-47 isn't just pushing through the air, it's eating it. We need to talk about the empty seat. The F-47 is a 2-seat-sized aircraft, but it only has one pilot. The space where the WSO, Weapons Systems Officer, used to sit in the F-15 is now a massive bank of processors. The pilot of the F-47 is not there to fly the plane. The AI, affectionately named Skyborg, flies the plane. The human is there to be the battle manager. The F-47 is designed to deploy with Collaborative Combat Aircraft, CCAs. These are the loyal wingmen. Think of the F-47 as a shepherd and the CCAs as the sheepdogs. The F-47 flies at 60,000 feet, silent and dark. It sends 4 Anduril Fury drones forward, 100 miles ahead. The drones turn on their radars. They scream electronically. They make themselves targets. When the enemy J-50s light up their radars to shoot the drones, the F-47 detects those emissions. The F-47 doesn't even have to open its own weapons bay. It can send a data link command to the drone. Launch on that bearing. The drone fires. The drone might get shot down. The F-47 turns around and goes home for dinner. This is the attritable mindset. The Air Force is willing to lose a $10 million drone to save a $350 million fighter. The F-47 is the node that makes the swarm intelligent. Without the F-47, the drones are just remote control planes. With the F-47, they are a unified kill web. If you're listening to this and thinking, this sounds too good to be true, you're right. Now comes the reality check. 1. The cost is unsustainable. The unit flyaway cost is rumored to be $350 million. That is not a fleet, that is a boutique collection. The Air Force originally wanted 200 of these. At this price, they will be lucky to get 70. If we only have 70 F-47s and China has 1,000 J-20s and J-50s, the Lanchester Square Law of combat kicks in. Quantity has a quality all its own. Even a Mach 3 fighter can run out of missiles. 2. The maintenance nightmare. Remember the ceramic Matrix Composites? They are miraculous, but they are brittle. If a mechanic drops a wrench on a ceramic wing, you don't dent it, you shatter the internal matrix. You have to replace the whole panel. Flying at Mach 3 stresses the airframe in ways we barely understand. The turnaround time for an F-47 sortie could be days. In a high-intensity war, you need jets that can land, refuel, and take off in 45 minutes. The F-47 might be a hangar queen that spends 100 hours in maintenance for every 1 hour in flight. 3. The tanker vulnerability. This is the fatal flaw. The F-47 has long range, but not infinite range. It still needs aerial refueling to cross the Pacific. The tankers, the KC-46 and the aging KC-135s, are just converted airliners. They are slow, huge, and light up on radar like a Christmas tree. The PL-15 missile has a range of 200+ miles. Their strategy isn't to fight the F-47, it's to shoot the tanker. If the tanker goes down, the F-47 pilot has a choice: eject over the ocean or glide into the water with a $350 million jet. The Air Force is working on a stealth tanker, KCZ, but that is years away. Until then, the F-47 is a Ferrari tethered to a gas station that is on fire. So, what is the verdict? Is the F-47 Pegasus a strategic masterpiece or a capital misallocation? The case for masterpiece: it restores the psychological barrier. For the last 10 years, China believed they had caught up. They believed the J-20 negated the F-22. The F-47 shatters that parity. It forces China to spend billions developing new defenses, new missiles, and new engines to catch up to Mach 3. It bankrupts the adversary just by existing. It is the ultimate fleet in being. The case for misallocation: we are fighting the last war's future. The future is likely small, cheap, and autonomous. We just spent $200 billion on a silver bullet manned platform when we could have built 20,000 autonomous cruise missiles. We built the ultimate arrow, but we only have a handful of them. My assessment: the F-47 is a bridge. It is the last great manned fighter. It is the machine that will teach the AI how to fight. The pilot inside is teaching Skyborg how to survive. In 10 years, the F-47 won't have a cockpit. It will just be a computer with wings. But right now, in 2026, the United States Air Force has looked at the speed limit of physics and decided to treat it as a suggestion. The Blackbird is dead. Long live the Pegasus. This channel relies on deep dive analysis. If you want to understand the systems that actually run the world, make sure you're subscribed to the Hidden Muster. Now, I want to hear from you in the comments. Here is the debate. If you had the $200 billion budget, would you build 70 of these Mach 3 monsters, or would you build 5,000 dumb drones to overwhelm the enemy with sheer mass? Quality or quantity? Let me know what you think. I'll see you in the next briefing.